quick recap of cross product and concept of vectors that we learned last time. So cross product of, yes, good afternoon everybody. Two vectors we saw last time by definition was given by this formula. It has a magnitude of product of mods into sine theta. It has a unit vector n cap which is given according to the right hand rule, okay, which we saw. So n cap is the unit vector perpendicular to both vector A and B and decided by right hand palm rule. Okay, so this is what we've understood till now. And we also saw that magnitude of A cross B, which is AB sine theta, becomes the area of the parallelogram formed by A and B. So that was the interpretation of the magnitude, whereas the direction is perpendicular to the plane of A and B. This is the two things we understood. Yeah, and then we also went on to see how to calculate A cross B in component form. So if A and B are given in component form, we represent A cross B. So represent the vector A cross B by this three-dimensional matrix determinant. The first row becomes ijk, the second becomes the components of E, and third becomes the components of B. Okay, and this further reduces to that formula EY BZ minus EZ BY into I cap plus EZ BX minus EX BZ J cap. And finally, so rather than remember this cumbersome formula, the easy method is to just work out the determinant of this matrix, which easily works out to this formula here. J cap. So this is the cross product in component form. So this is what we had learned about the cross product last time in detail. So I'd like to start this session with some example applications and then come to the worksheet problems where there are some easy and some reasonably tough kind of applications also. So we'll discuss everything with the worksheet 7. So let's start with some revision questions. Then we'll come to the worksheet. So let's start with something pretty easy, that A cross B has a magnitude which is √3 times A dot B. Okay. And magnitude of A is 2, magnitude of B is also 2. Then find magnitude of A plus B. We just start with this question. So good afternoon to everybody again, especially those who have just joined in the last couple of minutes. So we've just about started. We saw the review of the concept of cross product we discussed last time. And this is, we are doing a small exercise of review questions before we come to the worksheet number 7's discussion. Okay, so I just want you people to solve a few questions with me over here before we start with the revision, with the discussion of the last worksheet. Yes, Parth, that is correct. Very good. Yes, Sanya, correct. Vyapi, correct. Good. Saurav, check your calculation once. Dhruv, you also have to check. Viraj, correct. Vashisht, correct. Aditya, you have to check. Palak, correct. Dhruv, correct now. That's good. Harshvardhan, correct. Mehak, correct. Yashmit, correct. Good. Okay. All right. So let's just finish this up. Okay. So understand here that magnitude of A cross B is AB sine theta, and E dot B is AB cos theta. So mod of A cross B is equal to root 3 times A dot B. Yes, Shivam, correct. Aditya, just check your calculation once. Yeah, Aditya, you got it correct now. That is Aditya Vikram Singh. And Aditya Karfa, you have to check your answer once. Samarth and Ayush both got it correct. Okay, so this is telling me that sine theta is equal to root 3 times cos theta. Okay, which means that tan theta is equal to root 3. And this also means that theta is acute. Because had theta been obtuse, then dot product would have been negative. E dot B is a positive quantity. So that means I know that it's an acute angle. Because see, mod of A cross B cannot be a quantity with sign. So if mod of A cross B is AB's, I mean root 3 times A dot B, that means A dot B must be a positive quantity. Whereas if A dot B had been a negative quantity, then there must have been a minus sign here also. Okay, so that's, if we understand that A dot B is positive, so theta is acute. Okay, so this means that theta is 60 degrees. That's it. Now once you know that, you have to just substitute the formula. Okay, therefore, E plus V is root of A square plus V square plus 2AB cos theta. So in this you just substitute 60 degrees. So you will get 2 square plus 2 square plus 2 into 2 into 2 into cos 60, which is half. So you see you get 2. It should be your final answer. So this becomes the solution of this. Yes, Yojit, correct. You got it correct. Saurabh, you got it correct. Yeah, we are doing more questions. Okay. So hope this is all clear now. So next example is something like this. So vector E is 10 I cap and vector B is 15 I cap plus 20 J cap. Find A cross B by component formula method. And also by definition and by drawing vectors A and B in the xy plane. For this, you have to use the definition of A cross B, which is that A cross B is EB sine theta n cap. This kind of method. Okay. What about the direction, Dhruv? Aditya, check your calculation. Dhruv, your magnitude is correct, but A cross B will be a vector quantity, so you have to give the direction also. No, Dhruv, the direction you have to give in terms of unit vector. Yes, correct. Samarth, correct. Viraj, correct. Palak, correct. No, Yashmit, you have to check again. Okay, so the thing is very simple. If we are doing this by the component method, we can do one of two things. One is we can recall the two-dimensional formula. So that is ax, ay, bx, by, k cap. So just substitute the components. So it is 10, 0, 15, 20 k cap. So as you can see, it becomes 10 into 20 minus 0 into 15 in this determinant times k cap. So it just becomes 200 k cap. Okay. So this is like the most formula based method. Blindly, if I want to just substitute in the formula without using any property and all that, do this. Okay. Or I can alternately also do like this, that I can write A cross B as 10 I cap cross product with 15 I cap plus 20 J cap. Then use the distributive property. So this becomes 10 I cap cross 15 I cap, which should be 0, okay, plus 10 I cap cross 20 J cap. And then use the property that I cap cross I cap is 0, whereas I cap cross J cap is positive of K cap. Okay, so use that property here, so that becomes 200 K cap. So my E cross B becomes this. So these are the couple of things that we can do if we are solving by the component method. I'll come to the second part also, but for those who didn't work this out in the first part, yes. Yes. So now all of you have got this. Sanya, Tharv, Yasmith, Mehak. Yeah, so we can also solve it that way, that the angle between the two is 53 degrees. Okay. So this is the thing method, the definition or component method of solving the question. Okay. Now let's come to the second thing where we have to solve it by the definition and by drawing the vectors. So the second method, the vector E being 10 I cap and the vector B being 15 I cap plus 20 j cap. You can see that the vector E is of magnitude 10 and along x-axis, the positive x-axis. Similarly, the vector B we can see is of magnitude 25, okay, but at 53 degrees with respect to the positive x-axis. Okay. Because we can see that for this tan theta is 20 by 50, so that is 4 by 3, and theta is in first quadrant because x and y components are both positive. So it's the vector is lying in the first quadrant. So based on that information, now we can draw the two vectors, which in our xy plane will look like this. Okay. So that's the advantage with two-dimensional vectors. You can always draw the vectors and understand it that way also. So this is the vector E, suppose. Its magnitude is 10. Now in comparison to that, the vector B is like this. It's longer in length also, like this. And this angle is 53 degrees. Its magnitude is 25. Okay. So now you can see that if you calculate E cross B here, that's EB sine theta n cap. So that will become 10 into 25 into sine 53. Okay. And what about n cap? You can see it's coming out of the plane. If you point your thumb along E and your fingers along B, you can see your palm is pointing outwards. Okay. So A cross B will be, the n cap will be k cap. Coming out of the plane is coming. Straight coming out of the plane. Okay. So this becomes your E cross B. So this is how we can show that E cross B is ultimately 200 k cap. How we found the angle? I'll just show you a bit by using the component of the vector. See, dx is 15, by is 20, and both are positive. So theta is tan inverse of by bx, which here will become tan inverse 4 by 3 and quadrant 1. So how I know it's quadrant 1? Because both x and y component are positive. Yes, with respect to x-axis, and vector A is along x-axis only. Na? So A के respect में उसका angle 53 हो गया. Okay, so hope this question is clear to all of you people now by both the methods. Yes. Okay. So obviously the exam level way of doing this question will be directly by components. You don't want to put so much time into drawing the two vectors, finding the angle and all that. But this is just to show you that the two things actually correspond to each other. सर्वेश यहाँ पे रिजल्टेंट नहीं निकाला है, यहाँ पे वेक्टर बी का एंगल निकाला है विद रिस्पेक्ट टू ए. So B was at an angle of 53 degrees with the x-axis, and E is already along the x-axis. So that's why we are seeing the angle between E and B is becoming 53 degrees. So that's why in the sin theta formula here, we are substituting theta as 53. Understood? So there's मतलब resultant नहीं है बेटा, vector B and E के बीच में we are finding the angle. Okay, let's move on to another concept-based question I wanted to discuss. So next example. So the projection of vector E along vector B in component form and its magnitude. And then secondly, I want to find E perpendicular, that is the projection of vector E perpendicular to vector B. Okay. In component form again, and its magnitude. And third thing we want to find out here, find a vector C such that C is perpendicular to both E and B, and magnitude of C is equal to 3 volts. So this is what we have to calculate in this particular question. Just minimizing the question for you. So think carefully about each of the parts of this question. Okay. Just take your time. Think carefully about each of these parts. Okay, Aditya Vikram Singh, your first part answer is correct. But remember, in the first part, actually, I've asked E parallel as a vector quantity first. Okay. Only then you have to find its magnitude. First, find it as a vector quantity. Kevin, the magnitude of a vector cannot be a negative quantity. Okay, so you have to just adjust your answer properly. Previous question, beta. This part, second part to it. Okay. So second part we were using the definition A cross B, EB sin theta n cap. So this is how we use that. We drew the vectors A and B in the XY plane. The magnitudes are 10 and 25. The angle is 53. And you can see cross product's direction is coming out of the plane by using the right hand palm rule. So by using this, so that's how we got this. This was the second part of previous question. No, there was no third part, but do we part then? So this question has three parts. Okay, so let me explain the method first, then you come back to this. Okay. So irrespective of the fact that यहाँ पे vectors we cannot draw in the xy plane because they are three-dimensional, but that doesn't mean we cannot draw the vectors with respect to each other. Suppose this is one vector, we can always imagine another vector with respect to it is something like this. They can be three-dimensional vectors, but we can just draw them like this without drawing the xyz axis. So we are just imagining how the vectors are looking. So this is vector E, and this is suppose vector B, or let us interchange them. Let's say this is vector A and this is vector B, suppose. Whatever they are in component form. We substitute the values later. First, let's understand the meaning of the question. Okay? So it means that if I drop a perpendicular from B onto A here, then this becomes, this thing expressed as a vector becomes a parallel component of A to B. And similarly, if I draw another vector perpendicular to this, then this becomes the component of B, which is perpendicular, sorry, component of A which is perpendicular to B. This. So first of all, geometrically we have to understand what is the meaning of these two things, the perpendicular component and the parallel component. So if the angle between them is theta, you can see that the A parallel has a magnitude of A cos theta, and A parallel as a vector is along the vector, and A perpendicular has a magnitude of A sin theta. And its direction is perpendicular to B, but obviously in the plane of A and B. The vectors A and B you can see are forming a plane, so that this one is lying in that plane only. It's coplanar in that plane. And also we can see that A's parallel component vectorially added to A's perpendicular component is nothing but the vector E. So we can make advantage of this fact also. So this is our approach to the question. So having understood this now, what we do is step 1, we find this magnitude. So that is A cos theta. So the easiest way of finding this magnitude is it is A dot B divided by mod. Okay, so this is the first step. We calculate this thing. Okay. Then step 2, we express this A parallel in vector form. तो उसके लिए क्या करना पड़ेगा? We have to express it as its magnitude into some unit vector. So that unit vector will be what? It will be a unit vector which is in the direction of the vector B. Okay. So just a minute, there's a small correction here. This one is the vector E, and this one is the vector B. Okay. So what is the direction of this? It is B cap. Okay, because remember the direction of this vector is along the vector B. So this is nothing but the unit vector along B. So B cap क्या होता है? It is vector B divided by its magnitude. So once I've done this, it will give me this. Give me this in vector form. So that is done. And then step 3, I will substitute that in this. So that will give me the perpendicular component. So the next step here, step 3, to find the perpendicular component of A as a vector, use the relation that A perpendicular will become the vector A itself minus the parallel component, because the vector sum is this. Okay? So I'm just minimizing this and explaining this again. So see, in the diagram that I've drawn, we don't need to worry about x, y, z axis kahan pe hai, because we are drawing in 3 dimensions. So anyway, we will not be able to understand the 3-dimensionality. We're just looking at how vector A and B are related to each other if we draw them from a common origin. So vector A and B are related like this. So this is vector A, whatever its magnitude is. This is vector B, whatever its magnitude is, and theta is whatever angle between them. So if I drop a perpendicular from A's head onto B, so ये जो projection है, this is which one? This is the parallel component. और इसका जो perpendicular वाला component है, वो कौन सा हो गया? That has become the perpendicular component. Okay, so this is the component along B, and this is the component which is parallel to B. Okay, so now in this triangle, you can see what is the magnitude of this component. It will be A cos theta, and therefore what will be the magnitude of this perpendicular component? It will be A sin theta. Okay, and what is the direction in which the parallel component is lying? It's lying along B. Whereas what is the direction in which the perpendicular component is lying? It is lying perpendicular to B like this. Okay. So hope these two statements are clear to all of you. Okay. Yes, we have to find the component of B along, A along B and A perpendicular to B. So we have to find these two things. Okay. So now having understood these 3 statements, that parallel component का magnitude A cos theta है, उसका direction B के along. परपेंडिकुलर कंपोनेंट का मैग्नीट्यूड A sin थीटा है, उसका डायरेक्शन परपेंडिकुलर टू B है, बट इन द प्लेन ऑफ A and B, that is in the plane of this diagram, and that the sum of the parallel and perpendicular components equals the original vector E. Now how to calculate this? So the first step is we first find the magnitude of this component, which is A cos theta, using the dot product method. So we'll substitute A and B here and find out the magnitude. And second is, now we want to express this in vector form. So we have to multiply the magnitude with what? The proper direction. So direction क्या है? B के parallel है. So what it should be multiplied with? It should be multiplied with B cap. That is a unit vector which is parallel to B. Okay. So just do step 1 and 2 and calculate the first part. Then we'll come to the next thing. Okay. So just do step 1 and 2 over here and calculate the first part, where this is what we want to calculate. Okay. This thing. So just do step number 1 and 2 over here, and that will give you the answer to the first part. Then we'll come to step 3 and the answer to the second part. Saurabh, that is as per the definition. Okay, A dot B का definition AB cos theta होता है. Okay. So anyway, let's execute these steps. So just give me a moment here. Okay, so let's work out the first step or the first part of the question. So this is given to us. So first of all, let us find this, which is A cos theta, which is by definition going to be A dot B divided by mod B. Because you know by definition A dot B is how much? It is AB cos theta. Okay. So therefore, what is A cos theta? It is A dot B divided by mod B. So now what is A dot B? It is AX into BX plus AY into BY plus AZ into BZ. This is the definition of A dot B. Whereas what is the definition of magnitude of B? So what will be the definition of magnitude of B? It is square root of BX square plus BY square plus BZ square. So it just looks like a long calculation, but you know how to do this actually. So it is 2 plus 2, 4 minus 1. Okay. So that's how much? 3. Okay. And what is mod B? It is root of how much? 1 plus 4 plus 1, so root 6. Okay. You can see this is square root of 3 by 2. You can write this. This is the parallel component of A cos theta. So this is step 1. This is the component of A parallel to B. Or along the vector B in magnitude form. In magnitude form it is root 3 by 2. Okay. So just understand this step first, then we'll convert it to a vector. That's a vector sum beta. Devash, how it is becoming equal to the vector is because you can see this is the parallel component and this is the perpendicular component of vector A. Then इनका sum कितना हो जाएगा? It will be the vector original vector A only. It's like if this is AX, you're taking the x-axis along that parallel direction. Then this is AY. This is the perpendicular component. So their vector sum will be how much? E. Okay, so have you understood the point, Devash? Okay, now next thing we want to convert this good. Okay, so next thing we want to convert this to a vector. And direction of this as a vector is along the vector B, or its unit vector. Unit vector gives a vector direction is which one? B cap, where B cap is nothing but the vector B divided by its own magnitude. So B cap क्या होना चाहिए? Vector B divided by its own magnitude, which is I cap plus 2j cap minus k cap divided by its own magnitude, which is equals to 6. Okay. So this is B cap. This is a unit vector along the vector B. Therefore, now for my step 2, A parallel as a vector will become its magnitude, which is A cos theta, into its direction, which is the unit vector along B. This one. So a cos theta we just seen was root 3 by 2, and this is just now we are seeing I cap plus 2j cap minus k cap by root 6. Okay. So this will become I cap plus 2j cap minus k cap whole by 2. Correct? Or you can write this as I cap by 2 plus j cap minus k cap by 2, which both of these are the correct way of expressing it. So this becomes a component of A, which is parallel to B. So this here is, you can say, the projection or component of E along the vector B, okay, in vector form, in vector component form, becomes this one. Okay, so just take your time and understand these steps and ask me if there is any question about this. Okay, so earlier on we have found out the magnitude of this is root 3 by 2. Okay, that is your A cos theta is root 3 by 2. Now we are just using that in the step below to express this as a vector. Okay. And you'll see earlier that the vector B was this only, I cap plus 2j cap minus k cap. So I just use that value here. So this is a very critical step actually. This is the step where most people make the mistake. Okay. Because it's easy to remember A cos theta is A dot B divided by magnitude of B. But how to convert it into a vector, that is where your logic now comes in. Okay. So just write this down and understand it. Beta minus k क्या भी होगा ना, because vector B was this ना. Where is vector B? Oh sorry, my mistake. Yes, vector B had plus k cap. It was A which had minus n. So just we have to make a small correction, people. It will luckily not affect anything else. Just this has to be converted to plus sign. Now, vector B was I cap plus 2j cap plus k cap. Vector E had the minus k cap. Thanks for pointing that out, Sanya. So this is our final answer. Okay, so let's go over these steps again. Make sure you written the correction in this step here. It's plus k cap. This step over here. Just make sure that you got the correction. It's plus k cap. Right. So hope these steps are clear, and you have come up to here. This one. Okay. Now notice this vector. Before we move on to the next part, it has a very interesting relationship with the vector b. Okay. You notice what should be the relationship between this parallel component and the vector b. E parallel is this vector. It is 1 by 2 I cap plus j cap plus k cap by 2, right? This is what this vector is. Yeah. Okay. So this is what it is, or we can express it this way also. It is I cap by 2. Okay. Now it should have what properties? Should be along the vector b, or in other words, parallel to. Okay. It should be parallel to vector b. So let's check. What is vector b? It was I cap plus 2j cap plus k cap. So you can see that, notice that if you take bx upon ex, it is exactly equal to by upon ey. It is equal to bz upon az, which is in fact equal to plus 2. Exactly. So just see that, compare the two vectors, you see this relationship is true, which means that the vector b is exactly 2 times the vector e. Okay. Which means that kya ho raha hai? B is parallel to B. Sorry, A parallel. So this is A parallels x component, A parallels y component, and A parallels z component. So this shows us, so this shows that vector b is parallel to this vector. Wherever two vectors are parallel, either you can show that their direction cosines are same, or you can show that the ratio of x components is equal to the ratio of y components is equal to the ratio of z components, which should be a positive quantity. ये 2 की जगह 3 भी आया होता है या 1.5 आया होता है, it doesn't matter. But all the three ratios should be the same, and they should be a positive quantity. That means the two vectors are parallel to each other. Okay. Here, okay, by chance the magnitude of B is twice the magnitude of A parallel, but more importantly, because it is directly proportional with a positive quantity, that means they are by definition parallel vectors. So for example, if I had made some mistake in solving this, this condition would not have been correct. I would have got some mistake over here. So that would have told me, okay, what is wrong. Okay. So this is something that you can see. Sort of the projection concept we have done in the last lecture, where we had discussed about the applications of dot product. It is not in the previous lecture number 9. You will find it in the lecture number 8, applications, okay, of dot product. Previous lecture was purely about cross product. Achha, in NCERT, yeah, you will not find this in NCERT, which is why I would suggest that you refer to the module in our Iitians Hub module. You refer to that. So people, what Saurav is asking here is that he did not find the projection concept in NCERT. Okay. So yeah, I mean there are certain things here we are studying which are beyond NCERT, but you will find everything in the module. Okay, there will be some things every now and then which will not be there in your NCERT, but you will find them in the module. Okay. Yeah, in future chapters they will be there in HC Verma, and I will give you some. Let us finish vectors, then I will give you some additional books and all which you can refer to. Okay. But yeah, you have to understand it for NEET better. Projection concept is important. Okay. But for vectors, I would suggest that even HC Verma doesn't give a lot of theory. So you refer to my whiteboard notes and you refer to the module for your theory revision. You stick to these things. Okay. All right. Now let's come to the last part of this question. Now the third part of the, the second part of this question, we have to find this thing. We have to find the component or projection of E perpendicular to B, and this is in the plane, lies in the plane of A and B. So as we understood that if A and B are defining a plane like this, then both the parallel and the perpendicular component of E, they lie in this two-dimensional plane formed by the two vectors only. So this component and this component, they both lie in this 2D plane. So we have to find this one now. Okay. So for this, what we do is step 3. Use the relation which you can clearly see in the above diagram. The relation that if you add these two as vectors, if you add A parallel and A perpendicular as vector quantities, their sum is equal to what is the original vector E. You can see. So you can make use of this relation that A parallel plus A perpendicular is equal to the vector E. So that means I can easily find A perpendicular by subtracting the parallel component. Okay, so all I have to do is that. So A perpendicular will become the vector A, which I think was 2i cap plus j cap minus k cap, minus this vector which we just saw is I by 2 plus j cap plus k cap by 2. Just subtract these now. So the x component will be, no, that is magnitude. This we are talking about vectors. Okay. See, Vineet, Viraj. Okay. That is the different thing. That is, if you see the magnitude, this will be square root of A parallel square plus A perpendicular square. Why? Because they are at 90 degrees to each other. You understanding my point? Because E parallel and E perpendicular are perpendicular to each other. So it's basically something like this, that if you look at a vector in terms of its x component and its y component, what is the relationship in terms of magnitude? And the relationship in terms of magnitude is that it is root of ax square plus ky square. But what is the relationship in terms of vectors or components? It is ax I cap plus ay j. So just the way these two relationships hold, the same way this relationship holds with respect to this diagram. You can see that these are two perpendicular vectors, but they are such that उनका sum कितना है vector E. This, and because they are perpendicular, that's why if I convert this to a magnitude, I will get this relation. Okay, so hope this is clear, Viraj. So this will become 2 minus half, so that is 3 by 2 I cap plus 1 minus 1, so that is 0. Okay, and minus k by 2, so minus 3 by 2 k cap. This should become the perpendicular component of the vector. And its magnitude, we can now just find this way. Or we can use the other relation to find the magnitude. So it will become 3 by 2. Okay. Just go over these steps here. Let me just correlate the vector E first. 2i cap plus j cap minus k cap. So that's That's what you substituted here. So this last step you can simplify it a little. Actually, first you can take 3 by 2 common outside. So it is 3 by 2 into root 2, or you can also write it as 3 by 2. Both are correct, no problem. Write it like this or like this. Aditya, it's not that I've used k-cap method. I've just used this relation here, that the sum of the parallel and perpendicular component is equal to the vector. This is the method I've used. This is what we've used for finding the perpendicular component. So this is a kind of tricky part of vectors. So we'll do some more practice on this, don't worry. Okay, but just make sure you understood this particular question first. Yeah, we are coming to the last part. No, Devansh, you'll understand that we can't use cross product here because cross product gives a vector which is perpendicular to both A and B. Okay. So I'll show you some variations of this, what we can do. Yes, Yashmit, you will find some of these type of questions in the module also. All right, now next thing you have to understand here is that this perpendicular component should be such that first of all, E perpendicular plus E parallel should be equal to E. Okay, so let's check this. So that will tell us that okay, we got some correct answer or some wrong answer. So 3 I cap by 2 plus minus 3 k cap by 2 plus A parallel, which was I cap by 2 plus j cap plus k cap by 2. Okay, that becomes 3 by 2 plus 1 by 2, so 2 I cap. Okay. Then 0 plus j cap, so that's j cap. And then minus 3 by 2 plus half, so that's minus k cap. So that is equal to the vector E. So that's correct. Okay. So our first condition is satisfied, that yes, this is the case. Okay. Then secondly, what should happen? E perpendicular, we have to verify this, so let's do that, should be perpendicular to the vector b. Why? Let's go back to the diagram and understand. ये जो वेक्टर है ना, ये परपेंडिकुलर, ये इसके परपेंडिकुलर होना चाहिए v के परपेंडिकुलर. That was the condition. So let's just check. So let's just check that condition. So a perpendicular we just saw was 3 by 2 I cap minus 3 by 2 k cap, and the vector b we saw earlier was I cap plus 2 j cap plus k cap. So now therefore check their dot product. A perpendicular dot b कितना हो जा रहा है? 3 by 2 into 1 plus 0 into 2 plus of minus 3 by 2 into 1. So that is coming 0. So that's fine. So therefore they are perpendicular. So my second condition is also checked. And the third thing it has is that a perpendicular square plus a parallel square should be equal to a square. So let's check that. So a perpendicular we just saw has a magnitude of 3 by root 2. A parallel we saw earlier had a magnitude of how much? It was 3. No? A cos theta earlier. We just go back inside. Yeah, so a cos theta. Oh, sorry. It was, just check, it was root 3 by 2. Yeah, root 3 by 2. So let's just check. This was root 3 by 2. So now, therefore, a perpendicular square plus a parallel square is 3 by root 2 का whole square plus root 3 by 2 का whole square. So that is 9 by 2 plus 3 by 2. So that is 6. And that is equal to mod a square. Because mod a we had seen earlier was root 6. Because a was 2 I cap plus g cap minus k. So this also works out. Okay. So this also checks out that is correct. So it shows you that this vector has these important properties. Therefore, it must be the correct one. It's this vector in the diagram. You can see that it should be such that it's perpendicular to b. It should be such that the vector sum of a perpendicular and a parallel should give you the vector e. And it should also be such that because this angle is 90, the sum of the squares of the magnitude should be equal to a squares magnitude. So that is what we are seeking. Just go over this. I mean, we don't need this to solve the question. We've already solved the question. But I'm just showing you that that perpendicular component has these 3 important properties. Okay, people. So hope all the parts of this question are clear. I mean, the two parts are clear. We come into the third part, of course. Okay. So I'll take you back to the question. And now try and interpret the third part correctly. Third part में क्या करना है? Let's try and understand that carefully. So read the language of the question and understand the third part में क्या कह रहा है. Then think in terms of the diagram that we made. How will the third part relate actually? Okay. So understood what the question is asking. It's asking you to find a vector which is perpendicular to both A and B and its magnitude is 3 units. So now think in this diagram, वो vector कहाँ पे है? Where does that vector C lie in this diagram? The moment you understand that, that will become clear. See, so to answer your question, what is happening now? Vector algebra is something which we will use in applications in physics. So it is not so much about whether it is important from exam point of view or not. It is important that we should know this as a method in mathematics because we might be using it somewhere else in vectors in applications in physics. Yes, very good, Samad. It is along n cap, where n cap is what? The unit vector perpendicular. So in this diagram, where is the vector C? The C is perpendicular to the plane of vector A and B. ये जो पूरा plane है ना उनका A and B, which is the plane of the board, that is the plane of the screen. Okay, so that means C should be either coming out or going in. So there are two possibilities actually. There are two vectors going inside the plane or coming out. Okay. So now the thing is, see, this plane is not the xy plane, so it is not k cap or minus k cap. So we still have to find this out. Okay, so we have to understand one thing here, that the plane of the screen is not the xy plane, because vectors A and B are three-dimensional vectors. They are having all three components, x, y, and z. Okay, so we have to use cross product. Very good. Okay, so what we have to do is, that's where the third part becomes compulsory. So for the third part of the question, to find the vector C, mod C is 3 and C is perpendicular to both A and B. So to work out this part now, we have to make use of that relationship. Okay. Therefore, vector C is equal to plus minus 3 n cap, because it would be going into the plane or coming out, where n cap is the unit vector of A cross B. Okay. Or you can say B cross A also, because they're just negative of each other. So C will be like this. So now we have to basically just find n cap. So n cap क्या होगा? N cap will be equal to A cross B divided by its magnitude. Okay, like this. This is very simple because by definition, what is A cross B? It is AB sine theta into n cap. It's AB sine theta n cap. So that is nothing but mod of A cross B multiplied by n cap. Okay. So if this is the case, A cross B is its magnitude into n cap. So what is the unit vector? The unit vector of that is this one. Okay. So what we have to do next is first find A cross B. Okay. So A was the vector 2i cap plus j cap minus k cap, and B was the vector I cap plus 2j cap plus k cap. So next thing is we have to find the cross product. Then from the cross product, find its unit vector. And then we know C is either plus or minus 3 of n cap. there are two possible answers for C. So it's plus minus 3 of n cap. Okay, so this is clear, people. So next thing is you find the cross product. Okay? Use that three-dimensional matrix method to find the cross product. Yeah, I'll just check better. Sorry. Let me just check your answer. Yeah, I think it's correct. Let me just verify. Sorry. So A cross B will, let me do all the steps carefully. So IJK. नेक्स्ट रो में ए के कंपोनेंट्स आएंगे सो देयर वर 2 1 एंड -1. नेक्स्ट रो में बी के कंपोनेंट्स सो 1 2 एंड 1. Just check from above once. So these are the components of AB. So next step, I can write this as I cap with this matrix, this one here. So that is 1 -1 2 1. Then remember the middle term always comes with a minus sign. So minus j cap into these four terms, the first and the third row. So 2 minus 1 1 1. Okay. And then finally plus k cap with this matrix here, this one, the first and second column, excluding the k cap column. So 2 1 1. Okay. And next step, you finally solve this. You can see it is going to be 1, okay, minus of -2. That's 3 I cap. Okay. Minus of 2 minus of -1 j cap. Okay. And then finally plus of 4 minus 1 k cap. So this will become 3 I cap, okay, minus 3 j cap plus 3 k cap. So this is A cross B. Okay. And therefore its magnitude is square root of 3 square plus 3 square plus 3 square. So that is root 3 into root 3. Okay. बेटा वो determinant का rule होता है ना, when we calculate the determinant of a 3 by 3 matrix, the middle term comes with a minus sign. That is why you will remember in the cross product, the first term was EY-BZ minus AZ-BY I cap, but the second term actually becomes AZ-BX minus AX-BZ J cap. Okay. So this term actually can be written as minus of AX-BZ minus AZ-BX J cap. Okay. That's why that minus sign comes in between. Whereas the third term was EX-BY minus AX. So ये जो एक odd term आता है ना बीच में, so that for that we put the minus sign in between and keep the term normal. Whereas these terms come with plus. This comes with plus. So now n cap will become E cross B divided by magnitude of A cross B. So you can see it will become I cap by root 3 minus j cap by root 3 plus k cap by root 3. Or you can write it as I minus j plus k, the whole thing divided by. this is n cap. So now the vector C will be either positive or negative of 3 times n cap. That will become my final answer. Saurabh, I'm trying to understand the doubt you sent here. A cross B equal to C. No, A cross B is not equal to C, beta. That is the thing you have to understand. A cross B is a vector which is parallel to C or anti-parallel to C. I'm not saying that the vector C is equal to A cross B. I'm saying that the vector C has a property that it is perpendicular to the plane of A and B, and the vector A cross B also has that property. Okay. So that is why the vector C, what is its relationship with A cross B? You can see here that originally I had drawn the two vectors A and B like this. And drawn the vectors A and B something like this, let's say. So यहाँ पे A cross B का direction क्या है? It is into the plane. Okay. You can see that A cross B is equal to AB sine theta into n cap, okay, where this was that 3 root 3, its magnitude, into n cap, where n cap was the unit vector into the plane. Okay. And that unit vector we just saw, it was I cap minus j cap plus k cap, whole thing by root 3. That was that unit vector n cap. Okay. Now, what is the vector C? The vector C is something a little bit different than this. C is not equal to A cross C. Now, the vector C is equal to plus minus 3 n cap. Why? Because the vector C has a magnitude of 3, okay, and direction of C is perpendicular to the plane of vector A and B. So that means that C is either into the plane, in which case its direction is n cap, or coming out of the plane. That is minus n cap. So that is why the vector C is becoming, the vector C is becoming plus minus 3 of n cap. So that will make it plus minus 3 times I minus j plus k by root 3. Or finally we can say that C is plus or minus of root 3 into I cap minus j cap plus k. ये possibilities है vector C. So it is only directionally having a connection with A cross B. It's not having a connection in terms of magnitude. Okay, so hope this point is clear to all of you. So this is the thing about C. Yes, exactly, sorry. You've understood this, okay? All right, people. So those are the three parts of this question. So now next we'll work out some questions from the worksheet 7. Some typical questions I want to discuss, or at least give you hints, okay, so that you have more chance of working it out yourself. Okay. So just open your worksheets and just give it a minute. Okay. I just have to share the screen again. Once close it and reboot the program. So just give me a minute, people. I will be back online with the white screen. In the meantime, just take the worksheet out and go through it once. I will discuss with you. Okay, so people turning to worksheet 7 now. Just a minute. Yeah, so let's discuss some of the questions from worksheet 7. Right, so we will start with question number 1, because it's an easy question, but I just want to discuss the concept over here. So question 1, what we have to do is, now see, today we have discussed a lot about direction of vectors from unit vectors and things like that. Okay, so I'll explain how this works in a practical problem like this. So suppose we have one point E and another point B, and some object is moving along this straight line from A to B. So what happens is, for an object moving with a certain velocity, body or particle, whatever, moving from the point A, which has some coordinates given, let's say x1, y1, z1, to the point B, which has some coordinates x2, y2, z2. What happens is that displacement is nothing but the line joining A and B, is this vector. So the displacement vector is this. The straight line joining A and B, that arrow, is nothing but the displacement. So now if I know these two coordinates, I can directly write the displacement as x2 minus x1, that is the x component of displacement, plus y2 minus y1, that is the y component of displacement, plus z2 minus z1, that is the z component of displacement. So जो भी मेरे coordinates हैं, इनको substitute करके मुझे क्या मिल गया, displacement vector. So that's the first thing. So that will tell you how much the displacement is. Now secondly, if the velocity is uniform and of magnitude v, then what about the velocity vector? It is that magnitude into a certain unit vector, where n cap is the unit vector along the displacement, because the direction of v is along the displacement, because velocity is uniform. You can see that displacement is velocity into time. So they must be parallel vectors, as you can see in the diagram above. Okay. So जो भी मेरा AB line का direction है, वही मेरा velocity का भी direction है, and that is the same as the direction of displacement. Okay. So what I'll do is, from this now, I find the n cap, that is the unit vector along AB. So that n cap is nothing but the displacement divided by its own magnitude. So you found out this vector, and now just divided by its mod, so you're getting the magnitude, and velocity becomes nothing but whatever the speed is given to you into that magnitude. Understood? So in this particular question, when you work it out, you will see that the components are given such that this vector will come out to be how much? It will come out to be 3 minus 0, so that is 3 I cap, plus 5 minus 1, so that is 4 j cap, plus 2 minus 0, so that's 0 k cap. So this is the displacement vector. So this will become 3 I cap plus 4 j cap divided by its own magnitude. So magnitude of 3 I cap plus 4 j cap is 5. Okay. So this is the unit vector. So now the velocity will become the magnitude of the velocity, which is given to you as 25 meters per second, multiplied by the unit vector, which is this one. So 3 I cap plus 4 j cap divided by 5. So as you can see, the velocity vector is becoming 15 I cap plus 20 j cap in meters per second. Each component has a magnitude in meters per second. So that becomes my final answer. So more important in the answer is the concept of the question here. Hope it is clear to all of you. So क्या हो रहा है, initial और final point के coordinates दिए हुए हैं. Using those coordinates, we will find the displacement vector, and from the displacement vector, we will find that unit vector along AB. So that unit vector becomes the direction of the velocity vector. So to now express the velocity as a vector, you have to multiply its magnitude, which is 25 meters per second, with its direction given as a unit vector, which is this 3 I cap plus 4 j cap by 5. Okay. So hope this is clear to all of you people. Okay, good. Now next, moving on to second question is actually very, based on what we have done today, you will be able to do it, but since few students have asked me, so I'll just quickly write down here what you have to do in second question. You have to find the component of B parallel to the vector E. So you have to find basically B cos theta just in magnitude. So you don't have to find it as a vector. You have to find this, the component of B parallel to A as a vector, as a scalar. So that is nothing but E dot B divided by mod. Just use this. So just like we done earlier today, that thing. So that is your question 2. Okay. And similarly now in question 3, you have to work out the perpendicular component of this one. So for the perpendicular, in terms of magnitude, you can just do this. Okay. If you wanted to find out as a vector, then you should have used the vector sum. But if you just want to use the magnitude, you have to do this. This is for perpendicular component as a magnitude. Whereas what we saw earlier today, this relation you want to find it out as a vector. This is, we use it for perpendicular component as, or in vector form we use this. Whereas just in scalar form you use this, okay, because this itself tells you that magnitude wise this is what is happening because they are perpendicular to each other. So that is your connection, connected questions 2 and 3. Okay. Now in fourth question, you have to just use this relationship that n cap dot I cap is just cos theta, where theta is the angle of the unit vector n cap with respect to I cap, which is positive x-axis, along the positive axis. Why this is equal to cos theta? Because A dot B is AB sin theta. यहाँ पे magnitude of both the vectors is unity. Okay? So in the question it is given to you that n cap dot I cap is 0.6. So that means cos theta is 0.6 or 3 by 5. So that means theta is how much? It is 53 degrees. Okay? So with respect to your xy axis, in the xy plane of course, okay, here it is given that n cap is in the xy plane. Otherwise there are infinite such vectors. So n cap would be like this. Either it could be like this, or it could also be like this. It could also be like this. You take some n dash. This could also be. Okay. So accordingly, you find the unit vector. Okay. Yeah. So Viraj, what the question is saying is that n cap is a unit vector in the xy plane, such that n cap dot I cap is 0.6. This is what the question is saying. So from that we have to find n cap. Okay. So we understand that the dot product of two unit vectors is nothing but cos of the angle between them. So the fact that n cap dot I cap is 0.6, matlab we cos theta 3 by 5. That means theta is 53. So now in the xy plane, how many such unit vectors are there which are making 53 degrees with the positive x-axis? Only 2 such vectors are there. So accordingly, okay, so it will either be, so n cap will either become cos theta, that is 0.6 I cap, plus sin theta j cap, so that is 0.8 j cap, or it can also be the one where that angle is within on the fourth quadrant, so it is 0.6 I cap minus 0.8 j cap. ये दोनों vectors, they satisfy this property that n cap dot I cap is 1. Okay, because you see here that any unit vector making an angle theta with the x-axis, its magnitude is unity now. So it will be given by what? It will be given by cos theta I cap plus sine theta j cap. In this case, theta is either 53 degrees, quadrant 1, or minus 53 degrees, quadrant 4. ये दो possibilities हैं. Okay, so Viraj, hope this is clear. Okay, good. So next, let us move on to question 5. Now, question 5, thoda sa there is something missing in the question. It should have been actually just add the mod sign. The question should have been like this: that mod A is equal to mod B is equal to mod of A plus B by root 3, and this is equal to 10. Okay, so just add the mod signs. In the question, the mod signs are missing, so just add the mod signs. Okay, now you have to find A dot B. So it's very easy. Okay, see, using this relation, you can see that mod of A plus B is 10 root 3, whereas magnitude of A is equal to magnitude of B is equal to 10. So just expand this. So root of A square plus B square plus 2AB cos theta. This is 10 root 3. And substitute this here. So you will find the value of cos theta. Okay. And once you get the value of cos theta, you substitute here that A dot B is AB cos theta. Correct. Cos theta will come out to be 0.5. That's correct. So this will actually come out to be half. So substitute that here. You will get 10 into 10 into half. So 50. So that should be answer. So this is what we have to do in this particular question. Okay. Similarly, in sixth question, it's a very simple situation. In sixth question, it is given to you that A dot B is equal to magnitude of A cross B. So that means AB cos theta is equal to AB sin theta. So that means tan theta is unity or theta is 45 degrees. Now just use this for the magnitude of A plus B. Get the answer. Seventh question, people, sorry, sixth, that was the sixth question. Now coming to the seventh question, there is a correction in the answer key. Okay. The answer should be C. I think it's given as something else. It's given as B or D or something like that by mistake. So the answer should be, the correct answer should be C. Okay. Now what is the concept here? You have to find the area of triangle formed by vector A and B. So a triangle formed by vector A and B looks like this, let's say. You can draw the triangle like this also. So this is one way of expressing that, or you can draw the triangle this way also. You see both these triangles have the same area. If you draw them from a common origin also, they have the same area. And in both cases, they are different triangles, but they have the same area because that area will be base into height. So half base into height. Okay. So that is half of magnitude of A into B sin theta. Okay. So you can see it is half of mod A cross B. In any case, we have discussed the area of parallelogram is mod A cross B. It is half of area of parallelogram formed by A. So just calculate A cross B, then calculate its magnitude, and then divide it by 2. So just use the cross product method here. So you will get, yes. So use this one, mod of A cross. So for the given vectors, just calculate the cross product, then calculate its mod, and then divide it by 2. So you'll get the answer C. Okay, then I think 7th question should be easy. You should be able to work it out. Okay. So 8th question, man, should be easy. Try to work it out yourself. So question 8, make a vector triangle for resultant of the two forces given, or you can do, or you can use triangle law, or you can use components, or use xy component, because it's just two vectors you're adding, so you can just use two-dimensional component element. You get the answer. Okay, 9th, you have to use the same concept as question 1. Question 9, same concept as in question 1, where if the particle is going from A to B, in the displacement vector, it becomes the vector E. So it is x2 minus x1 plus y2 minus y1 plus z2 minus z1 as components. So this is also easy. Okay. Then 10th is easy. You have to find the perpendicular component. I mean perpendicular condition. So question 10, for A being perpendicular to B, just use the relation that A dot B should be equal to C. And from that, find the unknown. Using this now, find the unknown quantity X. It's a direct application, this one also. Now let's come to 12th. Now 12th is a more tricky question. So I'll explain 12th to you. So in question 12, something like this is happening. Suppose we have two vectors, A and B, and they are non-collinear. So they are defining a plane. And suppose now the vector C is also lying in the same plane. In such a case, the vector C is what we say coplanar to A and B. So this is an example of coplanar vectors A, B, and C, because they all lie in a common two-dimensional plane, which is in this case the plane of the ball, the plane of the screen. So understand here that if C has a component perpendicular to the plane of the screen, then C will not be coplanar. It will not be coplanar. A and B. Okay. So first of all, go through this statement once carefully and understand what is the meaning of coplanar vectors. Then we'll come to how to solve this. Okay. So how do we check if three vectors are coplanar or not when they are given in three-dimensional form? They are given in two-dimensional, then obviously. So next thing is how to check if A, B, and C, all three in three-dimensional component form, are coplanar. So let's understand this. Okay. So if C lies in the plane of A and B, that means C will be perpendicular to A cross B. Understanding the point? Because A cross B is perpendicular to the plane of A and B. By definition, it's along n cap, unit vector. It's perpendicular to the plane. So first of all, make sure you're clear about this statement. Understand this. If C lies in the plane of A and B, that means what is C's relationship with A cross B? It should be perpendicular. Therefore, C's dot product with A cross B should be how much? So this is the condition of coplanarity of three vectors. Now, likewise, we can also say that, or identically, we can say that B should be in the plane of A and C. Therefore, B should be perpendicular to A cross C, or B dot A cross C should be 0, or similarly A dot B cross C should be 0. So in other words, we get the relationship that if vectors A, B, and C are coplanar, then it implies that A dot B cross C will be 0. B dot A cross C will be 0. And C dot B cross A or A cross B, whatever, will be 0. So we can check any of these. Because actually the moment this first condition happens, it actually implies the second condition. So rather than write comma, this will imply this, and this will imply this. So this is how we will solve this question. So this is the condition for coplanarity of three vectors. So just note down and understand this condition first, then we'll discuss how to solve the problem. So if three vectors are coplanar, then the dot product of any one with the cross of the other two should be 0. That is what finally this method is telling us. Yeah, the question we are discussing is the 12th one, sorry. So the condition of coplanarity for three vectors. So what I can say of C with respect to A and B, the same thing I can say of B with respect to A and C, or of A with respect to B and C. So that's why this becomes the condition. Okay. So now in the given question, we just work this one out. So question 12 is given to us that the vector E is this one, 2i cap plus 3j cap minus 2j cap. The vector B is given to us as 5i cap plus some unknown quantity n, j cap plus j cap. And the vector C is given to us as minus I cap plus 2j cap plus 3j. So this is a known vector, this is a known vector, this is an unknown vector. So let's focus on this. And we have to find the value of n such that they are coplanar. That is, all of them are lying in the same plane. So since A and C are known vectors, let us focus on them first. So suppose A is a vector like this and C is a vector like this. Then now I want the condition that B should also lie in the same plane. B should either be here or wherever, but it should be in this plane somewhere. So the condition for coplanarity for the unknown vector B to lie in the plane of the known vectors A and C, B should be perpendicular to A cross C. That is, so in other words, B's dot product with this vector, which is A cross C, should be C. So this is the condition we install. Okay. So let's start by finding A cross C. A cross C कितना हो जाएगा मेरा? A cross C will be, just pick up those vectors and substitute them in this. So here, vector E is 2, 3 and minus 2. And the vector C is minus 1, 2 and 3. So this will become I cap multiplied with 3 minus 2, 2, 3 minus J cap multiplied with 2 minus 2 minus 1, 3 plus K cap multiplied with 2, 3 minus 1 and 3. Next step, we can solve this. So this is going to be 9 plus 4. So 39 cap, correct? Minus 6 minus 2, so 4. So minus 4 J cap. And then 4 plus 3, so plus 7. Okay. So this is becoming my A cross B. Now I have to find this condition, that B's dot product with A cross C should be 0. So that's what we do next. So this is A cross C. Therefore, B dot A cross C equals to 0 means that the vector B above, which was having components 5, n and 1. So 5 I cap plus n j cap plus k cap. This one's dot product with A cross C, which is this one. So 13 I cap minus 4 j cap plus 7 j cap. ये कितना है 0. So that means 65 minus 4n plus 7 equal to 0. So 4n will be equal to 72. So n should be equal to 18. The value of n. So this is how we are making use of this condition. Okay. Yeah, yes, I just come back to that question. Okay, people. So I'll be sharing this PDF with you, so you will get a chance to understand all the calculation in detail. But this is the method. So this was something slightly new for us, co-planarity of 3 vectors. So this you go through in detail from the PDF later. It's a bit of an advanced type of application of vectors. But yeah, more or less with this, we come to an end of this part. So just a couple of things I wanted to discuss with all of you now. So first of all, we have come to the absolute end of vectors. We are ready to now start the next chapter. However, the next lecture I will have will be a discussion lecture. It will, I will not straight away start with the scheming movement. Yeah. So the next lecture I have, we will do a discussion of some of the problems from the module, from the exercises. Okay. So we will take most of the lecture in that only. Plus we will see some more interesting type of application. Whereas after vectors is completed, we will start the next chapter, which in my track will be Newton's laws of motion, because that's a direct application of vector algebra in terms of solving. Whereas I think Hemant sir will be discussing calculus with you, which will continue into kinematics part 2. So yeah, I will discuss. So the last 3 questions of this worksheet, you try out yourself. Okay, their answers kind of lie in the questions that we discussed today. So for example, the 15 question somebody is asking me over here. So that involves the dot product of A and B, where A1 and A2, where A1 and A2 are actually unit vectors. So use that concept. Now, using the information given, you can find the angle between them. So dot product of A1 and A2, because they are unit vectors, is just cos theta. So if you just go through the hints and questions we've discussed up to question number 12, you will be able to solve 13, 14, and 15 yourself. In any case, if any doubt remains, you can always WhatsApp me and I'll send you. That will be enough. So I don't think there will be much difficulty finishing exercise or assignment 7. The more important thing is now you must get going with the module and try to keep this week's target by end of the week to complete exercise 1 and 2 of the module. Okay, exercise 1 and 2 together of the module, try to finish it up. I will anyway send you a list of some basic minimum questions you must do. But I think if you are up to date up to this point, you should not have too much difficulty actually completing both the exercises 1 and 2 of the module. Okay? To keep that as the target. And next thing we will do, I mean, after we complete the discussion of the module in the next week, will be Newton's laws of motion. For that, I will be sending you the PDF module also. And plus, from this point onwards, we will start discussing from some reference books also. So in the next lecture, I will be giving you specific names of reference books. Mostly, it will be H.C. Verma for doing questions. Another book called D.C. Pandey or Arihant publication D.C. Pandey for JEE type of questions. And also from time to time, we will refer to a book written by authors Resnick and Halliday. I'll give you the full name and details. Testing candidate for some detailed discussion of theory of physics, not for questions, but for some detailed. Erudov Aditya will not be necessary because the Erudov questions are included in the module and all that. But yeah, if you are specially aiming for Olympiad, then you can do Erudov also, and you can keep discussing with me. NCRT will also not be necessary. The module will give enough that is required. Pradeep, NCRT, all this will not be necessary for our studies. Okay. So you might have to refer to Pradeep at some later stage when your this thing is coming in. Internal exams for college and all is coming in. School, that is your 11th, 12th. But for our particular study over here, both in terms of theory as well as in terms of problem discussion, NCRT will not be necessary. NCRT or any other reference like that. So anyway, I will give you the list when we complete vectors in the next lecture. Okay. So in the meantime, just make sure you revise today's lecture problems very carefully. And yeah, you can always take the printout of module. There's no problem at all. It's just a lot of pages. But in any case, we will be supplying you with the printed module very soon. It's just a matter of logistically when we can complete that process of because they're all lying in some warehouse and all right now, and transportation is a problem. But as we told you in the PTMs also, that we will be supplying you with the physical copy of the modules also at some point of time, sooner than later. Okay, so don't worry about that. So anyway, that's it for today's lecture, people. All the best and stay safe and everything. And complete vectors as much as you can. Aim to complete maximum of workshop of exercise 1 and 2 from the vectors worksheet, okay? From the module. Module exercise 1 and 2, try to complete maximum questions, discuss all your doubts. That's it. Thank you, people. Yeah, Yasmith, if you can just send that question to me on WhatsApp, I will help you out with it. Okay, that in chapter exercise question.